Yo, yo, yo. Welcome, guys, to what day is it now? Day 17. Today, well, just quick update. I had a quant internship interview, and I can't lie with you guys. That problem solving required for the first semester stage is mad. Like, I mean, it would just take practice, but I can see like the level of thinking required. But it's just like I really have to knuckle down on my data structures. So I'm thinking, let me know if you guys think it's a good idea. So I'm thinking, um, I'm going to like revisit like just basic questions like arrays, queues, stacks, hashing, because this was very important. And then like obviously working with, like lists and tuples. Just really knuckle down on my foundations once again, like just cover it over again because I've already done it before, and then I'm gonna move back onto like binary trees, linked lists, and then obviously more complex topics like backtracking and so on and so forth. But like just generally like, you know, knuckling down on that data structures because it's just a recurrent factor, and like to be fair, like covering again, it's not gonna be like the last time I cover it. It's not gonna be the first time either, but you know, like practice makes perfect. I'm not scaring my dog by clapping, but yeah. Let's go into this video. We're gonna be solving subtree of another tree. It's a binary tree question, yeah, but you know, I already started it and like I did the question, did prep for it, so we're gonna do this question. Alright. So given the root of two binary trees, subroot and return, so root and subroot, return true if there is a subroot of root with the same structure and node values of subroot, or false otherwise. A subroot of a binary tree is a tree that consists of a node in tree and all of its node descendants. The tree can also be considered a subtree of itself. Okay. So it's giving us examples like 1, 2, 3, 4, 5, 2, 4, 5. So see, this is contained in here. But then it gives us the example of 1, 2, 3, 4, 5, 6, 2, 4, 5, still there, but it returns false. Do you guys know why it returns false? Drum roll, please. It returns false because there is a left child here and there's no left or right child here. So actually this would kind of look like no, 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 but this one went 6. No, because when you have the node, it has 3 properties. Like, you can see right here the 3 properties. Value, left, right. So even though the values are the same, the left and the right is not the same, so therefore it can't be a subtree because it's not the same nodes. But yeah, you get the gist. Like it really does make sense. But how would you attack this problem? Like how would you write it down? How would you kind of like start? So just before we get into the problem, like one thing I want to say is that it is the easiest to create a string and compare if the string exists. We need to know what type of traversal we are going to do. So with depth first, it's probably not gonna, I mean breadth first, and probably not gonna work because it's gonna go 1, 2, and then 1, 3, like. But if we're getting a subroot, we're going deep, like we're going deep into the tree. We know where we're going. We know what we want to compare. We want it to get the exact order. So for that reason, we're gonna use depth first search, also known as pre-ordered traversal. Like if you're American, you know, like. I mean, technically, yeah. I mean, I just hear Americans just say it all the time, so I'm just gonna say that. So what do we want to do? Wanna build a string. We want to append the values, return the string, compare the string of the subtree to the tree. If it is a match, which means it contains within the tree, then we say that we can safely say the subtree exists. Also, with a string, it works as well because you get nulls. Like, for example, like this, like 1, 2, 3, or like 1 null, 2, 3 null. But if you don't, it's really hard to identify those parts. So you know, like it's like yeah, you guys will 100% get it. Like 1,000,000%. The code is not hard. The concept, you just need to understand the little trick, because that's how they catch you out. So yeah, let's begin. Let's say public static string DFS DFS. This is the hardest one named algorithm. DFS string. Yeah, let's go that DFS string. This is the hardest part is naming the algorithm because it's absolutely mental. Actually, no, it's cool. So we're gonna say so let's get a count for that first position. If node is null, then we return null. Okay, then we're gonna say, right, Vim, guys, give me Vim. Can't live without it. Yeah. So then we're gonna say no, you need to define the string builder first. So string builder sb equals new string builder, and then sp.append node.val to get the first value, sp.append dfs string node.left. Yes, yank this because that's what it's called. Okay, get rid of that space. Let's say it's right. And then let's say return sp.toString. Then we can say that we're gonna get string full tree is going to be equal to dfs string root, because that's a full tree. String subtree is going to be equal to dfs string the subroot. Then we're gonna say if full tree dot contains subtree, then we're just going to say the hell, what are we returning? Yeah, I guess to return true. Return true. Just return false to be fair, to make the method happy. Right, let's see how this goes. Where the hell are you at? Append. Don't tell me it's a capital. Please. 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 Okay, that works. Now let's try to see if it submits. Successfully solved the problem. Boom, solved the subtree and method work. Hopefully I did a good enough explanation. If you guys agree with my plan, what I'm going to do about revisiting data structure so I get a better understanding, let me know if it's a good plan. If you have any other way that I should be able to prepare, let me know. Once again, thank you guys for watching. Thank you guys for subscribing. At 27 now, can we get to 50 by the end of June? Anyway, see you later.